So imagine for a second that, well, okay, first, this is our video for 5.11a, adding and subtracting complex numbers. To give some context and background for what we're about to discuss, I want to talk about taking square roots of negative numbers. If I were to try and take the square root of -1, it would be not possible to do when I'm talking about real numbers. And here's what I mean by that. The square root of a number means what times itself gives you that number. And so if I'm trying to figure out what times itself gives me -1, it would be hard because I would try 1 times 1, which is +1, and I could try -1 times -1, which is also +1. So it feels like there's no solution, but the actual matter is that there's no real solution. So there's no real number solution that would work. And we talked earlier in the year about the set of real numbers. It's whole numbers, natural numbers, integers, rationals, irrationals. That makes up all the real numbers. Well, today we're going to add a new number group called imaginary numbers. And they come from situations like this where you're trying to take the square root of a negative number. So it has no real solution. What we're going to do today, though, is say that its solution is I, which is the symbol we use to represent imaginary numbers. So we're going to practice for a second simplifying radicals, which we've been doing the last couple of units, but this time with a negative thrown in. So the first example I'm going to give you is an example that has a perfect square in the radical. So square root of -25. I'm going to have you rewrite that as -1 times +25. And then now I have two things and I'm going to simplify them individually. So the square root of 25 is 5, and the square root of -1 is I. And there's nothing left in the radical, so it's going to go away. When you pull out more than one thing, you multiply them together. So that's going to be 5i. Okay, so that's an example of a radical that's a perfect square with a negative inside. So here's one where you don't have something that can be simplified. So -7, square root of -7. Again, I'm going to rewrite that as -1 times 7. The 7 can't factor or simplify, but the -1 can. It simplifies to I. And so I'm going to write that as I radical 7. Now I like to write the I in front because it makes it clear that it's outside the radical. Sometimes if you're writing the I on the right-hand side, it can be hard to tell, was it supposed to be in the radical or outside the radical? But that's not wrong. This is just how I'm going to be doing it. All right, so that was a perfect square radical, not factorable, a prime, no factoring involved in this radical. Let's look at one that partially simplifies. So let's try -12, square root of -12. So I'm going to read that. I'm going to read that. I'm going to rewrite that as -1 times, and now I'm going to factor 12. It's 2 times 6, which is 2 times 3. And now I can simplify the pair of 2's. That brings 1 2 out. And the -1 simplifies as I. So I'm going to multiply those together. That gives me 2i, and then there's still a 3 inside the radical. All right, now these three answers are terms. They don't have anything being added or subtracted to them, and we're going to talk about that in just a second. But first, I want to show you or talk about the general form for what's called complex numbers. So complex numbers are the set of all the real numbers plus all the imaginary numbers. Those together make one big set of numbers called the complex. And the general form for all of those numbers is a plus bi, where a stands for the real part of the number, the part that belongs in the real number system, and BI stands for the imaginary part of the number. So all of these numbers, in fact, any number we've worked with can be written like that. So, and this isn't part of your notes, but I did explain this in class. I'm just going to show you real quickly. So A plus BI is general for all complex numbers. Let's say you had this real number 27. Okay, that's a real number. There is no imaginary part, but if you're going off to college next year and you're going to take college algebra and you're asked to take an integer and rewrite it in complex number form like this, you would just put 0i because there is no I part, so put 0i. So A is 27 and B is 0. Similarly, if you had just an imaginary part, what number do you think you'd put in for the real part? You'd put in 0 because it doesn't have a real part. And then a number that has both parts could be anything like -7 plus 10i. So it has these two parts like that. Okay. So complex numbers is all the real plus all the imaginaries in one huge set of numbers. Now let's look at some complex numbers that we're going to be adding. So let's say I had 4 minus 3i plus 5 plus 6i. Right? So that's two complex numbers. Now it's 4 terms, but two complex numbers because this 4 minus 3i is one of them and 5 plus 6i is the other one. And you're going to just combine like terms. So 4 and 5 are the real parts. Those are like terms. That makes 9. And then -3i and 6i. Now you're going to combine these the same way you would combine if you were adding like terms that had variables. So you're going to do the math on the coefficients. -3 plus 6 is +3 and then I. One thing I want you to understand though is I is, in this context, I is not a variable. Variables represent unknown values. You can plug stuff into variables, it might change. This I right here, you do math on it like a variable, combining like terms, exponent rules, and all that kind of stuff, but it is not a variable. It represents a specific value, which is the square root of -1. Okay, so down here in this section, I'm going to write in some problems. I want you to copy them and then pause your video and try and work them, okay, and then come back after you've done that. So the first problem is square root of -81. The second one is the square root of -5. 3 is square root of -18. 4 is parenthesis 7 plus 2i plus parenthesis 3 minus 4i. 5 is parentheses 2 minus 5i minus parentheses 5 minus 2i, and then 6 is the square root of -27 plus the square root of -48. So take a minute, pause your video, work those, and then come back to get the answers. All right, for number 1, I'm going to rewrite that as -1 times 81. You could also do a factor tree on the 81 if you like. -1 simplifies to I, square root of 81 to 9. So you should have 9i for that one. Square root of -5, rewrite as -1 times 5. The -1 simplifies to I, and the 5 can't factor or simplify, so it stays inside. I squared to 5. -18 is -1 times 9 times 2. Or if you want to do your whole factor tree, it's -1 times 3 times 3 times 2. Either way, you're pulling 1 3 out and an I out. So that will give you 3i square roots of 2. On number 4, you're combining like terms. 7 plus 3 is 10. and 2i, and negative 4i is a negative 2i. On number 5, notice that you are subtracting the second complex number. That is going to require distributing the negative sign. So that will give me a negative 5 and a positive 2i that I'm going to be combining with the first complex number. So 2 minus 5 is negative 3. Negative 5i plus 2i is negative 3i. And then the last one, number 6, square root of negative 27, I'm going to write that as negative 1 times 9 times 3. Square root of negative 48, I'm going to write as negative 1 times 16 times 3. And of course, you could do factor tree on 9 and factor tree on 16 if you like. So simplifying this first one gives me I and 3. Simplifying the second one gives me I and 4. So now I have 3i square roots of 3 plus 4i square roots of 3. And we actually don't need to stop here. Notice that they both have matching radicands. So they're both square root of 3. So when that happens, we can simplify more by doing math on the coefficients. 3i plus 4i is 7i radical.